Okay, let's get started. So, last session of the day. How's everyone doing? You can hang in there? Okay, cool. Let's get started. So this is infrastructure testing with Pester, or testing 1, 2, 3. A little bit about me. My name is Brandon Olin. I am at SRE at Stack Overflow. Hopefully you know what that is. I'm also a Microsoft MVP, Cloud and Data Center Management, and I am Dev Black Ops on most things on the internet. And so that's where, if you want to talk to me on the internet, that's probably where I'll be. Let's talk about what is software testing in like 3 or 4 bullet points, which I will probably murder. Just so to provide context so we can talk about infrastructure testing later. So software testing at a high level is an investigation conducted to determine the quality of a software product or service under test. It provides an objective, independent view of the quality of software. And it verifies that the software is fit for use. So that's software testing 101. So it verifies one or more of the following. It verifies that the requirements that guided its design and development are correct, that the software responds correctly to all kinds of inputs and outputs, performs its function within an acceptable time. It is sufficiently usable, meaning it's fit for purpose, and it can be run in its intended environments. And it achieves the result that its stakeholders desire. So let's see how we can apply some of those bullet points to infrastructure testing. And I'm going kind of fast because I have like 80 slides. So just so you know. So infrastructure testing is the validation of the operation of a system. Some examples of this could be, does this website respond with a 200, meaning that HTTP server is okay? Is that Windows service running, true or false? Is a certificate expired, or sometimes more importantly, isn't it about to expire that I need to take action on? Is the current state of the system what I expect it to be? And are these infrastructure properties correct? And this could be a very arbitrary set of properties that I just want to validate that they're what I assume them to be. And is the system operating to the customer's expectations? That's really the only important one here. So why would we want to test infrastructure? We want to validate that our current state matches the expected state. And we want to notify us when those states differ. And ultimately, we want to perform sanity checks before and after changes and provide some guardrails for our automation. So let's look at some examples of that. Blue-green deployments. Does anyone do blue-green deployments or know what they are? Yes? Okay. Anyone not know? Okay, cool. You've seen Indiana Jones and the Raiders of the Lost Ark when he flips the idol. That's a blue-green deployment. Okay. I could not put the image here, otherwise they'd probably pull the slide down. But in a real-world sense, let's say I have a website, a web server, and I want to upgrade it or do some type of migration. I should probably validate that service is in a known state. Here in this contrived example on the right, I'm testing that a load balancer is up, that the site responds with 200. It has 2 servers, A and B, and those are both up. It's safe to proceed. I know the state, it's a healthy state, I can do a migration. I do some type of automation, I migrate it to a new set of servers. Did that actual migration succeed? Do I wait on my users to tell me if that succeeded or not? Yes. They're the ultimate source of truth. So that was our green state. We've now migrated to our blue state. Let's run those tests again to see how that website performs. Ideally, everything's green across the board. So we can use that kind of blue and green deployment in a test to gauge that our migration succeeded. Let's talk about another example of validating settings. So here is an example of, I have some configuration in Azure that I would like to validate is what I expect it to be. So maybe I want to know that MFA is enabled for all of the administrators in the subscription or in the tenant, that all my any public endpoints require HTTPS. I have no VMs with a public IP address. Just in time is enabled, and I did that for you. Yeah. and all storage accounts are encrypted, HTTPS is required for those, etc. So there are many ways we can do those validations. In this talk, I'm going to show you how you can do that, or show you some ideas on how you can do that with Pester. Here's another example of another test you can do before you do some type of operation. So you want to verify the state of something before you proceed. This is similar to a blue-green deployment, but I'm not migrating to another instance. In this example, I want to patch some server. In this case, it's our turbo encabulator. So we're going to install some patches. I want to make sure that this service is in a healthy state before I do that. Here, I'm going to run some Pester tests to say, yes, my, and I'm going to screw this up, hydrocoptic marsal veins, that service is up, the logarithmic casing is up, and our lunar wane shaft is up. Yes. The lotus-o-deltoid type, or the main windings, is type of lotus-o-deltoid. Our panamadric fan spurving bearings are in direct line, and oh crap, our grammar meters are not up. So this server is not in some healthy state. I probably should not patch it. I need to bail out of my automation and maybe do some type of manual intervention before I continue. And no, Stack Overflow does not have a service called Turbo Encabulator, but that would be pretty cool. So why do we test again? Ultimately, we want to go fast. We want to be safe. And we want to bail when things are unsafe. To put that another way, in a kind of a CI/CD pipeline context, CI/CD pipelines allow you to go 200 miles an hour. Tests are your seatbelts, airbags, anti-lag brakes, traction control, collision avoidance, and autonomous driving systems, so you can go 200 miles an hour without killing yourself or others. So, make sense? So, testing is good. So now let's look at some PowerShell-based testing tools. Pester is one you should all be familiar with and know and love. Operation validation framework, you may not be familiar with, but I'll go into a little bit about that. The assert module, which is kind of a helper library that you can use in Pester. PSHEALTHZ is one of my modules that I've written that kind of plays on the operational validation framework. WATCHMEN, which is also another play on OVF. And if you have any others, you can hit me up after this and we can talk about some other, testing related tools that kind of ride on top of what Pester does. All of these ultimately are using Pester in some way. So Pester, the ubiquitous test and mock framework for PowerShell. We should all be familiar with describe and context and it blocks, mocks, etc. All those functions it provides. Here is an example function to get the answer to the universe. Here would be a simple Pester test to validate that that is correct. And here is the result of what that would look like. So we say, yes, we're going to run the get answer to universe function, and the answer should be 42. So the operation validation framework is something that plays on top of Pester. So this was originally created at Microsoft by Jim Truer. I've since taken over maintainership of it a couple years ago. And what this does is it kind of allows you to put your Pester tests into a certain folder structure in a module and allows you to use a module as a vehicle to distribute your Pester tests and version them and get all the benefits of a module. So you can publish them to a gallery, download them, search for them, version them, et cetera, run certain versions of tests, and it's really just using PowerShell modules as a vehicle to do that. But ultimately, what it's doing is it's executing Pester tests that are kind of riding along inside that module. So it has really two simple commands, get operation validation and invoke operation validation. Get operation validation will inspect the PS module path on your local system, look for all your modules, and try to determine if they look like they're an OVF module that has Pester tests and kind of give you some objects back. Invoke operation validation will take that resultant set of objects and invoke Pester and do a couple extra things if you'd like to. So you can say, here would be kind of the example folder structure of that. So say we have a module called myapp.ovf. We have our PSD1, we have optional PSM1, In the case of OVF, it really doesn't need either of those, but good module practice would be to have a manifest if you ever want to publish it somewhere. But technically, OVF doesn't care about a PSM1. It's just using a module as a vehicle for publishing. But we have this folder called Diagnostics. Inside that Diagnostics folder, we have two folders called Comprehensive and Simple, and inside those, we have our Pester tests. The difference between Simple and Comprehensive is really, maybe I have some Pester tests that would, check that have some Windows services are up. That's a very simple test that runs in less than a second, or very quickly. But maybe I want to run a fairly long-lived performance test. Those things you would kind of move into a comprehensive folder, and this is a way that you can group your tests and only selectively run one or the other. This is an example Pester test to test that a website responds with a 200. So you'll notice one thing here is a default. This is a feature of Pester, which not everyone is aware of, is that inside a Pester script, you have your describe and it blocks, but it is just a normal PowerShell script, and you can put in a parameter block at the very top and provide some defaults, which means that you can have Pester execute this and also override those defaults when they make sense to do that. So this is a Pester test that's going to test the PowerShell gallery by default, but if I can run invoke Pester and pass in some other parameters and make that any other website or any other status code I want. So I've made a fairly generic test that I can reuse. This can get pretty powerful when you put it in OVF, and I can make generic Pester tests, with maybe some same defaults in module, ship that, and then people can download that, execute that, and then override that for whatever specifics they have in their environment. So if any of you are familiar with SCOM and love it, no one? I liken OVF to SCOM management packs, basically. So you have a management pack to test Windows Server. You have one that tests Active Directory, SQL Server, et cetera. You can, if you choose to, make OVF modules that test SQL Server, Active Directory, application XYZ, publish them to your internal PowerShell repository, version them, et cetera, without using SCOM, just straight PowerShell. Excited? Yeah, okay. Here's another example of a Pester test that would be bundled with inside OVF. Let's say we want to test some Windows services. So I have a describe block here that I've broken out into critical and important services, and have created a list of services and some arrays. You can also, within Pester, tag Pester tests as another way to group things. OVF also allows you to selectively execute Pester tests based on those tags. So you can get fairly involved in how you want to build your Pester tests and categorize them: simple, comprehensive, tag XYZ, tag ABC, et cetera, and only execute, maybe I just want to run, check my critical services every 1 minute and, check my important services every 5 minutes or something like that. Here's an example of what OVF does in action. So like I said, it's only 2 commands. It's pretty basic. I will run get operation validation, pass it some module name. I'll get back a collection of tests. I can take those tests and I can pipe them to invoke operation validation. And internally, what this is doing is just running invoke Pester, wrapping that in a little bit of extra objects. But you can see there, you can have a list of failing and passing tests. So that's OVF, like in a really high level. But we'll play on that in a little bit. So the assert module, does anyone use the assert module, with Pester? No? Oh, okay, cool. So assert is it's a PowerShell module that provides some extra assertions that you can execute within Pester or outside of Pester to test some more advanced things. So I want to compare some arrays, or I want to assert the things are equivalent but very specific equivalency tests, or something is like something else, and it can be kind of fuzzy. are things that are exactly the same. There's, I think, a couple dozen different types of assertions you can run in this, but it provides some extra little power that you can bundle into your Pester tests. Here's a Pester test to validate that my domain admins are who I think they should be. So, and I'm faking this. I'm not actually, in the real life, you would actually call into AD and get your actual list of domain administrators. You probably wouldn't hard code your actual administrators in this array. But you would potentially have a list of domain administrators in a source control in like a text file or CSV or something like that. Have that in a testing repo and say, this is our blessed list of domain administrators. Let's go run a Pester test to get that and then compare that to the actual state that's in AD. The assert module is providing this function here called assert all. So instead of in Pester, where you would say, pipe should be, XYZ or whatever, you can say the actual state, assert that all of these are true, that are, everything in the actual array is in the approved array. And then maybe we can provide a custom message. And this message has a little bit of parameters that you can pass in here to say, this is what my actual state would be, this is what was missing from that, and how many there were. So when you execute this, when you have this one list person, which is me, who I snuck into the domain admin list, you would have something like this. So you run Pester, your int block is all domain administrators are approved, but you it said, okay, one unauthorized domain admin, and it would list the differences in the array. Now you can do that in just normal PowerShell with comparing arrays, but the assert module provides us some helpers to make that a little cleaner. But I would encourage you to look at the assert module. It has a whole bunch of helper assertions to do some kind of advanced comparisons. All right, so PSHEALTHZ. This is another module that I wrote a little bit a while back that plays on the OVF test idea. And what PSHEALTHZ is it's an implementation of the health endpoint monitoring pattern. And what this really is I have some system out there and I want to validate the state of it, but I don't know the internals of it. But I have it exposed as some type of endpoint that I can query for its health. And that's all me as a monitoring system need to care about, is that it has an endpoint that I can query. How it measures its internal health is up to it, and it can vary between systems. Me as a monitoring system don't need to care. And that makes it easier to maintain a monitoring system when I don't need to care about how to monitor 1,000 different services. I just need to hit one endpoint, and it will tell me if it's healthy or not. So what PSHEALTHZ does is it creates a PowerShell-based REST endpoint on your system. So you can create basically a simple web server running in PowerShell, listening on port 80 or 443, or however you want to configure it. And when you query that with invoke REST method or curl or whatever, you can ask it to execute OVF tests and return the results in JSON. It is assuming that you have those OVF tests already installed on the machine, and you'd probably do that with DSC, Puppet, Chef, or however you want to configure your servers. But it's going to run OVF tests on that machine, but it doesn't need to care about it, or your monitoring system doesn't need to care about it. You just say, query this endpoint, get me back some JSON. Here's how you would set up PSHEALTHZ. You would run start healthz listener, give it a port, maybe a path, so /health. If you want to do SSL, you do 443, pass it in a certificate, and it would start in the listener on your system. You can inspect that listener. You can see it's running on port 8080. Its path is health. In this case, I have no authentication. In real life, you can do things like you can set up some token authentication, or you can do some Windows authentication as well. Here is how you would execute PSHEALTHZ with invoke REST method. I'll just query my local system, port 8080 /health. I'll get back some JSON, invoke REST method, hopefully converted it to an object, and I can see my health. It's true, but it actually didn't execute OVF in this case. It returns back a message that you can see here that it responded, but it actually didn't execute tests. You have to tell it what test to run. Or you can tell it to list the available test to run. So you can give it a query parameter, say, execute all these tests, or execute a certain test. It gave you an extra property here of all the available tests to run. So I can run maybe the OVF Windows Server module, or the network, or the AD module or something like that. We can list our available tests. They all came from this module. We can invoke that those OVF tests with invoke REST method, pass in a query parameter of module equals OVF Windows Server. We'll get back a result, and we can say, no, it's not healthy. Return false. It gave you all the tests that were run, how long it took to run, and then it will have an array of all the test results. This is actually the Pester test results that you would see normally. And also, it would split out the failed tests into its separate collection. You can query that failed test collection to see exactly what test was run. Service property status for WinRM should be running. That looks very pestery because it is. It came from the operating system describe block, context availability, what script was executed, what the actual Pester message was, which was I expected that service to be running but got stopped. And this is something you can just query on all your servers if you have this running. So that's PSHEALTHZ, like in a high level. So WATCHMEN is another play on OVF that I created. So I was in like this little kick of playing with OVF for a while, you can tell. So WATCHMEN is a test runner for a notification system for OVF. So Pester OVF will execute tests and tell you something failed, but they won't take actions based on that failure. So that's what WATCHMEN can do for you. So WATCHMEN provides two simple commands: get WATCHMEN test and invoke WATCHMEN test, and can execute various actions based on failing or succeeding tests if you would like to do that. So I can execute the test, send an email, write to the event log, send something to InfluxDB, which is a time series database, write to a log file, execute some arbitrary PowerShell script block or file to do whatever you want to do, send a Slack message, send something to syslog, etc. So a WATCHMEN file is a simple DSL that defines what OVF tests to execute and what actions to take on success or failure of those. So here I'm going to say, I'm going to execute myapp.ovf. That's the OVF module name that I want to execute. And I want to notify these various endpoints or actions when things fail. So I would like to write an entry to a log file and send a Slack message, and I'll provide a token to do that. When I execute that, when I get that, I will run get WATCHMEN test, pass it the path to that script file, get back an object. I can pipe that to invoke WATCHMEN to actually run that. This is something that you could just schedule with Task Scheduler or something like that, or have your monitoring system execute OVF, or have something else execute OVF. Here's an example log file result, which will show I executed an OVF test, an important service was not running. We'll show you the result there. And here is a result if you did that executed the Slack notifier. So we basically just send a post to a webhook in Slack, pass in all the options from WATCHMEN, and it will tell you, oh my God, everything's on fire, panic. But you can do a lot of things with WATCHMEN, especially if you just have it execute the PowerShell script, and you can have it do whatever you want to do in PowerShell. It'll just get sent an object basically into a script file and do what you want. So Infrastructure testing. Let's look at some example, like real world examples of how you can combine OVF, Pester, other things like POSHBot, which is a module I wrote to do chat ops, and how, the interesting things you can do once you start hooking all these things together. So with inside Slack here, I'm using POSHBot, and I'm going to execute a custom command I wrote called smoke test, which is just PowerShell code that will do invoke REST method on my local host and execute an OVF test through PSHEALTHZ, get me back a JSON, and send that back into Slack, and tell me, I executed these tests, and which ones failed or not. So you could say, with inside Slack, I want to smoke test some random server and query its health endpoint. I don't need to care exactly how it is monitored. Maybe some other team maintains that. I just need to get the health status, and I can do all that right within Slack. Something else I've done before is compliance audits with Pester. So I mentioned like the domain admin one here. So I've done SOX controls within Pester before and have those run, every hour, every 5 minutes to validate that these controls that we're saying we're compliant or going to be compliant for, that we actually are compliant. And I have proof that we are, and I'm testing this, every 5 minutes and not 5 minutes before the auditors come. So here we have a basic describe block in Pester. In your case, you would have your own code to go get your actual domain administrators from Active Directory or Azure Active Directory. Import your approved domain administrators, which in our case, I usually keep in a source control repository that only certain people can modify. And when they do modify that, that's in your Git history. So you can see who is modifying, who is being approved, and who's not. And this is just a simple Pester test to say, does this list equal that list? And that's really what all the Pester is doing, does this left thing equal this right thing? Is this domain administrator supposed to be a domain administrator? Is this service supposed to be up? Is this amount of free space supposed to be, 0? Things like that. So Pester can be applied to test really anything you want. I like this example because this is something that your auditors will love. So it may take them a little bit to get their head around doing all this stuff in code and not screenshots that you email to them and put in a Word doc, because that's what auditors are used to. But once you get past that, they will like this, especially when they see the commit history of the approved list and who changed and why did Joe Schmo make this change and not the approver who's ultimately responsible for who's your domain admins. Here's another fancy one you can do, wiring up. So if this is Grafana, if people don't know what this is. Here I am combining other things like getting metrics on my Windows servers and putting them into InfluxDB and then showing them in Grafana. I'm also executing WATCHMEN tests and sending that to the InfluxDB action. So I'm sending Pester test results as true-false metrics into a time series database. So you may not be able to see this right here. This value here is 0 and 1, meaning true and false, meaning the test passed or it failed. And that is a performance metric, or you can measure that like a performance metric over time. So I'm executing tests, and as they fail, they will become a 1 in the time series database, or they'll be 0, and I'll get a timestamp. And now, hey, I can graph these test results over time. If you add tags to that, then you can also create a Christmas tree at the bottom here, where you can say, this test had this tag of IIS, this was another test that tested this service for SQL, you have a SQL tag, and you can do some fancy stuff from Grafana to query those values from your database, and then kind of basically do a loop and say, okay, was the value 0? Okay, it's up. Was it 1? It's red. And now you have a Christmas tree dashboard, to show the health of your system. Does anyone have any questions on like that part right there, or anything I've shown before? Yeah.
Are you putting the results of your test into text files, or
In this example, the test results are being sent as metrics into a database. So when a test fails, you can think of it like a performance metric. It has a numeric value and a timestamp. The value is 0 or 1, and it has a timestamp for when it executed. Those results, in this case, get sent to InfluxDB, which is like a high-performance database for doing metrics. And then you can graph them here, saying 0 or 1. And you can basically do some conditional styling, basically, to create these green and red values here. And you can do it in InfluxDB. You can do it in any kind of database that you want to store this metric data in. The top ones here are CPU and RAM. That was actually just native performance counters that I got out of in this case, it was Telegraph that was capturing performance metrics on the system. But I'm also inserting Pester results into the same database. But I can combine these together to where I can see the normal performance of the system, maybe some stats about uptime and cores and sockets and my free space and stuff, but also layer on the Pester results over time. So, any other questions before I move on? I'm like going super fast. I'm like early. No? Okay. Because I know we all want to go to the party. So let's talk about some good practices. Focus on tests on what the user sees, not necessarily what you are most interested in knowing. When you're creating monitoring of systems, ultimately we're doing this for the user. We want to know before the user knows that something is bad. So look at tests that would indicate that a user would typically see, like, is the website up? Yes or no? The user is going to see that. They may not see or care that the disk space is full or getting full. And even that kind of test doesn't tell you that the system is up or down. It's a nice test to see in the background, but ultimately it doesn't tell you anything useful to the application's point of view. You can add those later, but I would say if you're starting to do infrastructure testing, start off at the very basic. Does it work or does it not work? You can improve that over time. What you do here is you start small and you iterate. So, yes?
What's sort of the mindset behind the simple and the comprehensive? The simple are the user-facing. The idea was the simple user-facing. They're very quick. They're very efficient. And then if something's broken, then you do comprehensive to try and understand why the root cause.
Okay.
And that can be more extensive and exhaustive.
I didn't know the history behind that, simple and comprehensive. Thank you. These tests, yes? Oh, sorry. The intent of the simple and comprehensive was to do the start small and iterate. So let's create some simple tests to do some basic validation of a system. And when those don't maybe pass muster, we'll create some more comprehensive tests later on. Is that correct? No?
If the simple tests all succeed, happy days.
Oh, okay, got it.
If one of them fails, the question is why did it fail? And then the comprehensive tests are supposed to do the root cause analysis.
Oh, okay, got it. So the simple test will do some basic validation, and if those did not succeed, you can run the comprehensive to do more root cause analysis. Thank you. These tests should be in version control. Ideally, as close to the application as possible. The way I typically have done this in the past is I will have a Git repository per application or per service. Within that, I will have code to manage the application, maybe deploy the application. The documentation for the application should also be in that same repository, in my opinion. Also, the tests to validate or to monitor that application should be in that same repository. If it's not, and these are separated out, it's highly likely that things will get out of date, out of sync. Maybe you maintain this application, someone else maintains the monitoring of the application. They may not have the right context to do the correct monitoring for the application. So the more centralized you can get these things together, the better it will be ultimately. Use configuration management to deploy these tests. Doesn't matter which one you do, just do something. Just deploy these in some type of CM tool, Puppet, Chef, Ansible, DSC, not copy paste. Here's something that would be pretty good to do. Application owners should probably author those tests for the applications that they own. How many people here are responsible for monitoring a system that they actually don't know how it works? That's a lot of people. Are you the right people? You think you should be writing the tests for something that you don't know how it works? Nope. So application owners ultimately should be responsible for knowing how their application works and how to test that their application works. That can be a hard thing to do, especially with various skill levels of application owners. It could be developers, it could be business analysts, it could be system analysts. It'll vary across the board. The trick is to figure out how you can make that as easy as possible for them to create the tests. Once those tests are written, you want to automate those tests into the environment using some type of configuration management tool. So ideally, I check in an update to a Git repo, magic happens, which is my CI/CD pipeline, and it appears on my system. That's how the application owner should perceive that. We all know it's not that easy, though. But ultimately, what we want to do is we want to make it easy to do the right thing. So we want to make it easy to write tests. We want to make it easy for the right people to write those tests. We want to make it easy for those tests to land on the system. We want to make it easy to actually, monitor these systems. If we don't do that, then we just run into friction all over the place, and then it's not, and we just end up with a subpar experience. So that's all I have. Thank you very much. Like I said, my name is Brandon Olin. You can find me on the internet at DevBlackOps. If you have any questions, you can ping me on Twitter or after the session here. So thank you very much.